Okay boys, we're moving on to matrix multiplication. Now it's not true that any two matrices can be multiplied together. Sometimes it just can't be done. So we need a way to determine under which conditions two matrices, let's call them A and B, can be multiplied. I've got a little diagram here that will help you remember. So I've got matrix A, which has a certain dimension. It has a certain number of rows and a certain number of columns. Then we have matrix B. It will have its own set of dimensions in terms of rows and columns. Now it's a fact that two matrices can only be multiplied if the number of columns in the first matrix, we're calling it A here, is the same as the number of rows in the second matrix, which we're calling B. Okay, so that's what that's all about. Now, the other useful bit of information you can glean from this diagram is that the dimensions of the resulting matrix, which you could call by some other letter, but in any event it's a result of multiplying A by B, it's going to have the dimensions of the number of rows in the first matrix times the number of columns in the second matrix. So that's a handy little diagram for some sort of multiplication questions that you might get. And I'll move on to those now. Let's look at some examples, and there's a bit of a trick question as part of this, but not initially. So the first job is to find the result of multiplying A by B. We could get that a new pronumeral like C, but we won't. We'll just multiply out A and B. Okay, so what we're going to do is this. Let's rewrite it neatly. AB equals 1, 2, 3, 4 times B is 5, 6. Now what we need to do is multiply, as I like to say, row by column and then row by column. Okay, here we go. So AB equals 1 times 5, I'll put in the working out just for this example maybe, 1 times 5 plus 2 times 6. And then the next row is 3 times 5 plus 4 times 6. Okay, and tidying that up, we get 5 plus 12 is 17, and 15 plus 24 is 39, and that's our answer there. Okay, quite a straightforward example, that one. Notice a couple of things. The dimensions of A and B are not the same, but that doesn't mean we can't multiply them out, and you need to revert to the previous slide to see why. So that's the main feature there. We knew we'd have an answer. Now let's have a look at BA. Well, the problem here is that the dimensions of B is 2 rows, so 2 rows by 1 column, isn't it? And the dimensions of A, well, that's a 2 by 2 matrix. Now notice that these numbers here do not match, so we can't calculate BA. It will not result in a matrix. Okay, it will not result in a 2 by 2 matrix because it just can't be multiplied in the first place. Now that leads to another important fact, and it's not just about the dimensions of the matrix here having to have certain features. A common fact, a fact in matrix multiplication is that in general AB does not equal BA. So the commutative law of multiplication, we call that, does not apply to matrices. If AB does happen to equal BA, well then that's just one big coincidence. Okay? Alright. Okay, with this one you might want to press pause while you read the question. Now in this one we've got what's called a scalar, haven't we? The 2 out the front. What that means is I could get rid of that 2 by multiplying everything in matrix A by 2. In fact I could, and that's what I could do, but I won't do that for this problem. Okay, so let's work out the first part of this by working out 2AB. So what have we got? Well, this is what we've got. We've got 2AB equaling, let's leave the 2 out there as I said, and then what we're going to do is, of course, row by column, and then go to the next row, row by column, row by column. Okay, so here we go. So negative 1 times 2 is negative 2, and 0 times 0 is 0, so that comes to negative 2. And then over in this cell here, we get negative 1 times negative 1 is positive 1, and then plus 0 times 1 is 0, so our answer there is positive 1. Okay, next row is negative 1 times 2 is negative 2, plus 2 times 0 is 0, so our answer is negative 2. And then finally, negative 1 times negative 1 is positive 1, and to that I add 2 times 1 is 2, so it comes to 3. Okay, so that is 2AB, 2AB. Alright, now what we've got to do is find BA. And one thing we should have picked up from the previous slide is that AB will not equal BA. Okay, so BA equals, well actually I'm going to rewrite this because I'm not too good at going backwards with my matrices. So B is 2, negative 1, 0, 1, just copying that out from above, and A of course is negative 1, 0, negative 1, 2. Okay, multiplying these out, we get 2 times negative 1 is negative 2, plus negative 1 times negative 1 is positive 1, so it's negative 2 plus positive 1, equals negative 1. And then the next row by the next column, the same row by the next column is 2 times 0 is 0, plus negative 2, isn't it? So it's negative 2 is my answer. And then 0 times 1 is 0, plus 1 times negative 1 is negative 1, so negative 1 would go there. Just to recap on what I did there, 0 times negative 1 is 0, plus 1 times negative 1 is negative 1, so that's where I got the negative 1 from there. Okay, next one is 0 times 0, which is of course 0, plus 1 times 2 is 2. Okay, so that is BA, and as you can see, that is not the same as AB up here, is it? It's not the same as AB up there. That's what I would have expected. Now what we do is we add a weight. Okay, so here's probably a good time to bring this 2 back into our matrix. Okay, that 2 there. And all we do is we multiply each cell by 2. Okay, so what we're going to do is say that what we're going to do is get rid of a bit of this and make it a bit more room. Okay, now, so what we're going to say is this: 2AB plus BA is equal to, let's have a look. Well, 2AB is equal to negative 4, 2, negative 4, 6, and to that we need to add BA, which equals negative 1, negative 2, negative 1, 2, and that is going to equal, finally, just simple addition now here, negative 4 plus negative 1 is negative 5, 2 plus negative 2 is 0, negative 4 plus negative 1 is negative 5 as well, and 6 plus 2 is 8, and that is our final answer for 2AB plus BA.